Jai Gurudev. Good morning, student. Today we will learn preparation of hydrogen. Different methods of preparation of hydrogen. This is the first one is preparation of hydrogen from acids. So if I take HCl is the acid reacting with magnesium forming magnesium chloride and hydrogen. Zinc reacting with H2SO4 forming ZnSO4 plus hydrogen. The other methods are there. Preparation from alkali. Zinc react with sodium hydroxide forming sodium zincate plus hydrogen. So this is your alkali. The alkali again reacts with silicon. Silicon is the metal. Is sodium silicate plus hydrogen. So bases reacts with metal gives you the hydrogen gas. Next one, preparation from water. So 2H2O, if we do electrolysis of water, we are getting hydrogen and oxygen. Remember, in presence of acid, we have to do the electrolysis in presence of acid. So next one is your preparation from methane. Methane, we know the formula of methane is your CH4 reacting with the water. So this carbon takes the oxygen forming carbon monoxide and then hydrogen. Now another method, from water also you can prepare. From cold water you have to take sodium mercury amalgam plus water. Now you consider, if you directly metal if you add in the water, then vigorous reaction takes place and then firing may occur. So we have to take sodium mercury amalgam. In that case, less amount of sodium is exposed to water, less heat is generated. So we have to take sodium mercury amalgam reacting with the water forming sodium hydroxide and hydrogen. Reacting from hot water, zinc react with the water forming zinc oxide plus hydrogen. Iron react with the water forming iron oxide plus 4H2. This is ferroferric oxide. This is an example of mixed oxide. This is iron reacting with the water forming this one. The next one, when steam is passed over hot coke, so coke reacting with the steam forming carbon monoxide and hydrogen, this mixture is called your water gas. A mixture of carbon monoxide and hydrogen is called water gas. Now from water containing sulfuric acid. Now if a water contains sulfuric acid, the ions present in the water containing sulfuric acid are, from water we have H positive, OH negative, from this one also H positive comes, then SO4 dinegative. Now what happens, this hydrogen is positive charge, so goes to your cathode. Cathode is negative charge. The 2 hydrogen plus 2 electron gives you hydrogen at the cathode. At anode, OH negative goes. OH and SO4 dinegative both has a probability to go to the anode, but since OH requires less discharge potential, therefore OH is going to discharge at anode. So OH negative, we will take OH plus electron. So if I consider 4 OH, so we have 2H2O plus O2. Now laboratory method of the preparation. Laboratory method preparation is important. Now you have to take granular zinc reacting with H2SO4 dilute. So we have getting the ZnSO4 plus hydrogen. Remember, we have to take the H2SO4 in dilute form. We cannot take HCl, HNO3. HNO3 is an oxidizing agent, so we cannot take HCl also. and we cannot take the concentrated H2SO4, because if I take concentrated H2SO4, then sulfur dioxide is produced reacting with the hydrogen. The hydrogen produced that react with the concentrated H2SO4 gives you sulfur dioxide. If I take your concentrated HCl, then it may produce fumes of volatile HCl, and that is why it is not used. If I use the nitric acid is a double rule. It acts as an acid as well as an oxidizing agent. The hydrogen first formed reduces to nitric acid and then various oxides. So these things are not ignored. The main special thing is that in this preparation of hydrogen, along with those products, we have some impurities. So ASH3, then PH3, H2S, SO2, CO2, oxides of nitrogen as impurities, present as impurities in the lab method of preparation. Now these ASH3 and PH3, for removing those impurities, we have to pass the product formed through 3 bottles containing silver nitrate solution, then lead acetate solution, then potassium hydroxide solution respectively. Then this silver nitrate solution removes the ASH3 and PH3, then lead acetate solution removes the H2S, and KOH solution remove the rest, sulfur dioxide, carbon dioxide, and oxides of nitrogen. Now after doing that, finally hydrogen is collected over anhydrous CaCl2. You remember anhydrous CaCl2 we have taken, which absorbs the traces of moisture present in hydrogen. So that is how we will get the pure hydrogen. Thank you for today's student.